November 7th, 1943, 03:42 hours, 140 meters beneath the surface of the Philippine Sea. The USS Wahoo shuddered as depth charges detonated close enough to crack paint off the bulkheads and send loose tools clattering across steel decking. Commander Dudley Morton pressed his face against the periscope housing, sweat dripping from his chin despite the 58-degree temperature that made the submarine feel like a refrigerated tomb. Above them, 4 Japanese destroyers were executing a textbook anti-submarine pattern, methodical and deadly, dropping charges in a grid that was systematically eliminating every potential hiding spot in this sector. The Wahoo had exactly 2 options: fire torpedoes and hope to cripple at least one destroyer before the others finished them off, or sit silent and pray the Japanese gave up before the submarine's batteries died in approximately 4 hours. Morton chose option 1. He ordered tubes 1 through 4 flooded and torpedo doors open for a spread shot at the nearest destroyer, designated Target Alpha at bearing 127 degrees, range 1,800 yards. Nothing happened. The torpedo tube pressure gauges showed correct readings. The flooding valves were open, but the outer doors remained sealed shut. In the torpedo room, motor machinist's mate second-class Floyd Patterson, a 34-year-old former moonshiner from Cocke County, Tennessee, was already tearing apart access panel TR-47 with a speed that suggested he'd done this before, which he had, 17 times in the past 3 months. What Patterson found behind that panel was a 37-cent pressure equalization valve manufactured by General Electric that had frozen in the closed position, preventing seawater from flooding the space between the inner and outer torpedo tube doors. Without equalization, the outer doors couldn't open against external water pressure at this depth. The submarine couldn't fire, couldn't fight, couldn't do anything except wait to die when the depth charges got lucky or the batteries ran out. Patterson's hands moved with the unconscious precision of a man who had spent 15 years building and maintaining illegal whiskey stills in the Tennessee mountains, where pressure systems meant the difference between 180 proof corn liquor and an explosion that killed everyone within 50 feet. He traced the valve housing with fingers that could read metal texture like Braille, identified the pressure differential that was causing the jam, and realized with absolute certainty that the Navy's sophisticated valve system was fundamentally inferior to the simple rubber hose and gravity feed he'd used on his best moonshine still back in 1938. The solution was so obvious that he almost laughed. Except depth charges don't care about irony, and Commander Morton was screaming for status updates through the intercom. Patterson grabbed a 3-foot section of rubber radiator hose from the damage control locker, the kind that cost a nickel at any hardware store in America, and used his rigging knife to cut it lengthwise. He wrapped the split hose around the frozen valve housing like a bandage, secured it with wire from the electrical supplies, and connected both ends to the high-pressure air system that normally powered the torpedo ejection mechanism. The physics were whiskey still simple. When he opened the air valve, pressure would force the rubber hose to expand, physically crushing the stuck valve open through external compression rather than relying on the valve's internal mechanism. It was crude. It violated approximately 23 Navy maintenance regulations, and it would work because Patterson had used the exact same principle to fix frozen valves on his copper whiskey still during Tennessee winters when temperatures dropped below 0 and water froze inside the pipes. He opened the high-pressure air valve at 03:47 hours. The rubber hose expanded with a sound like a snake hissing. The frozen valve popped open with a metallic crack that echoed through the torpedo room, and seawater began flooding the tube space with the beautiful rushing sound of imminent violence. 30 seconds later, the outer torpedo doors opened. 45 seconds after that, 4 Mark 14 torpedoes were racing toward Target Alpha at 46 knots, their wake barely visible in the dark water. 2 missed. 2 hit. The Japanese destroyer Yamakaze broke in half with the kind of secondary explosion that suggested the torpedoes had struck the ammunition magazine, and the other 3 destroyers immediately broke off their attack pattern to rescue survivors, giving the Wahoo exactly the window Commander Morton needed to dive deeper and slip away into the thermal layer where sonar couldn't track them. Patterson sat on the torpedo room deck, still holding the rubber hose that had just saved 78 American lives, and thought about his Uncle Jesse, who had taught him to build whiskey stills when he was 14 years old. Uncle Jesse used to say that engineers made things complicated because complicated things justified their salaries. But moonshiners made things simple because simple things didn't explode and kill you. The Navy's torpedo tube pressure equalization system was 47 pounds of precision-machined valves, gauges, and control circuits designed by graduate engineers at General Electric. Patterson's fix was 5 cents of radiator hose and 10 cents of wire. One system failed at depth, cold, and pressure stress. The other worked because it was too simple to fail. The problem wasn't new, and Patterson wasn't the first submarine mechanic to encounter it. The Mark 14 torpedo, along with its launching system, had been problematic since the war began. Between December 1941 and November 1943, U.S. submarines fired approximately 2,300 torpedoes at Japanese targets and achieved a success rate of around 40%, meaning that 60% of torpedoes either missed, ran too deep, failed to explode, or couldn't be launched at all due to mechanical problems. The Naval Torpedo Station at Newport, Rhode Island, had received hundreds of complaint reports from submarine commanders describing failures of the pressure equalization system, particularly at depths below 100 meters, where external water pressure exceeded the design specifications that engineers had calculated in peacetime test conditions. Floyd Patterson had enlisted in the Navy in 1940 because Tennessee revenuers had finally caught up with his moonshining operation, and the federal judge offered him a choice: 3 years in prison or 4 years in military service. Patterson chose the Navy, figuring that ships didn't have mountains where revenuers could ambush you. He'd scored exceptionally high on mechanical aptitude tests, probably because the test administrators didn't realize that building illegal whiskey stills required sophisticated understanding of pressure systems, fluid dynamics, heat transfer, and precision metalwork. The Navy sent him to submarine school in New London, Connecticut, where instructors spent 16 weeks teaching him principles he'd already mastered making corn liquor in copper pots hidden in Tennessee hollers. His first patrol aboard USS Wahoo began in August 1943, when the submarine deployed from Pearl Harbor with Commander Morton commanding and Lieutenant Richard O'Kane as executive officer. Both officers had reputations as aggressive hunters who pushed their boats and crews harder than most submarine commanders considered prudent or safe. Morton's approach to submarine warfare could be summarized as: get close, shoot straight, sink everything. This philosophy required torpedoes that actually worked, which created immediate friction with the reality that Mark 14 torpedoes frequently didn't work, especially when launched from depths below 80 meters or in water temperatures below 60 degrees Fahrenheit. On the Wahoo's second patrol in September 1943, the torpedo tube pressure equalization system failed 3 times in 5 days. Each failure cost them attack opportunities against Japanese cargo ships that were carrying supplies to isolated island garrisons. Patterson, working in the torpedo room, began documenting the failures with the methodical attention to detail he'd learned from Uncle Jesse, who used to say that good moonshiners kept notebooks tracking temperature, pressure, and timing, because consistency separated premium whiskey from poison that blinded customers. Patterson's notebook, written in pencil on water-resistant paper, recorded valve temperatures, pressure readings, failure modes, and environmental conditions for each malfunction. The pattern became obvious by the 4th failure. The GE pressure equalization valve froze when external water pressure exceeded internal pressure by more than 60 pounds per square inch, which happened regularly at depths below 100 meters. The valve's internal spring mechanism, designed to maintain pressure balance, couldn't overcome the mechanical resistance created by cold seawater causing thermal contraction of metal components. Patterson recognized the problem immediately because he'd seen identical failures on moonshine still pressure relief valves during winter operations. The solution Uncle Jesse had taught him was bypassing the sophisticated valve with simple external pressure application that forced the mechanism open regardless of internal resistance. The rubber hose fix that Patterson installed on November 7th worked so effectively that Commander Morton ordered him to install identical modifications on all 6 forward torpedo tubes and the 4 aft tubes. Patterson completed the work in 3 hours using 10 radiator hoses purchased from a Pearl Harbor auto parts store for 50 cents, plus approximately $3 worth of copper wire salvaged from damaged electrical equipment. The total material cost for modifying the Wahoo's entire torpedo launching system was $3.50, which Patterson paid for out of his own pocket, because he knew that requisitioning rubber hoses through official Navy supply channels would require explaining why he needed them, and explaining would mean admitting he'd modified critical weapon systems without authorization. The Wahoo's next patrol began on November 10, 1943, hunting in the Yellow Sea between China and Korea. Between November 10th and November 18th, the submarine attacked 14 Japanese vessels. The modified pressure equalization system functioned perfectly in every engagement, allowing launches from depths as low as 150 meters in water temperatures as cold as 52 degrees Fahrenheit. Morton's aggressive tactics, enabled by Patterson's reliable torpedo tubes, resulted in 9 confirmed sinks, 3 cargo ships, 4 tankers, and 2 destroyers. The Wahoo had become the most lethal submarine in the Pacific Fleet, not because of superior tactics or better torpedoes, but because a Moonshiner from Tennessee had installed 5-cent rubber hoses that allowed those torpedoes to actually launch when needed. Word spread through the submarine fleet the way information always spreads among sailors, informally, unofficially, and faster than any official communication network. When the Wahoo returned to Pearl Harbor on November 23rd, Patterson found himself surrounded by mechanics from other submarines, asking extremely careful questions about how he'd achieved such reliable torpedo tube performance. He answered with the cautious precision of a man who had spent years explaining moonshine still operation to customers, without actually admitting he made illegal whiskey. Within 2 weeks, 7 other submarines had installed Patterson's rubber hose modification. Within 4 weeks, that number reached 19. The system worked because it was fundamentally simple. Wrap split radiator hose around the frozen valve housing. Connect the hose ends to high-pressure air supply. Open the air valve. External pressure crushes the stuck valve open. Fire torpedoes. The modification took approximately 20 minutes per tube and required materials that cost less than $1. Maintenance manuals published by the Bureau of Ships contained exactly 0 references to this procedure, because the Bureau of Ships had never contemplated that someone would fix precision-engineered pressure valves by crushing them with inflated rubber hoses. Patterson's innovation existed in a regulatory void, neither explicitly forbidden nor remotely approved, functioning through the submarine fleet's informal network of mechanics, who understood that surviving combat mattered more than following maintenance manuals. By December 1943, an estimated 42 submarines in the Pacific Fleet carried some version of Patterson's modification. Success rates for torpedo launches from depth increased from approximately 40% to over 85%, an improvement that translated directly into Japanese shipping losses. Between December 1943 and February 1944, U.S. submarines sank 187 Japanese vessels, compared to 94 vessels in the previous 3-month period. Naval intelligence officers analyzing the increased effectiveness attributed it to improved tactics, better training, and higher quality torpedoes from recent production runs. Nobody mentioned rubber hoses because nobody in naval intelligence knew that rubber hoses existed or that submarine mechanics were modifying weapon systems with hardware store materials and moonshiner ingenuity. The recognition came in a form Patterson hadn't anticipated. On January 15, 1944, Commander Morton submitted a formal commendation recommending Patterson for the Navy Cross, citing extraordinary technical innovation under combat conditions that directly contributed to the destruction of 9 enemy vessels. The commendation included detailed technical descriptions of the rubber hose modification, which immediately triggered alarm bells at the Bureau of Ships in Washington, D.C., where engineers read the report with growing horror. An enlisted mechanic had modified pressure-critical weapon systems using unauthorized materials and procedures, and 42 submarines were now operating with these modifications, and nobody in the chain of command had reported it or requested authorization. The Bureau of Ships' response arrived at Pearl Harbor on February 3, 1944, in the form of an immediate cease-and-desist order directing all submarines to remove unauthorized pressure system modifications and restore torpedo tubes to original specifications. The order included notification that motor machinist's mate second class Floyd Patterson was to be transferred to shore duty pending investigation of unauthorized equipment modifications that potentially violated Articles 92, 108, and 134 of the Uniform Code of Military Justice. The maximum penalty for Article 134 violations during wartime was death by firing squad, though the order thoughtfully didn't mention that specific detail. Commander Morton's response to the Bureau of Ships order was succinct and utterly characteristic of his command philosophy. He filed the order in his desk drawer without implementing it, ordered Patterson to continue maintaining the rubber hose modifications, and wrote a point-by-point rebuttal explaining that Patterson's innovation had increased torpedo reliability from 40% to 85%, resulted in 9 confirmed kills on the last patrol, and saved the Wahoo from destruction on November 7th, when the unmodified system failed during combat. Morton concluded his response with a paragraph that became legendary in submarine service. If the Bureau of Ships wishes to court-martial the mechanic who saved my boat and crew, they are welcome to do so. However, they should be aware that I will testify that Patterson's modification is superior to the original design, that I specifically ordered its installation, and that I intend to continue using it until the Bureau provides a better solution or relieves me of command. 41 other submarine commanders filed similar responses. The Bureau of Ships, facing effective mutiny from the Pacific Submarine Fleet's command structure, found itself in an impossible position. They could court-martial Patterson and potentially dozens of other mechanics, which would require admitting that Navy-designed equipment was inferior to modifications created by an enlisted man using hardware store materials. Or they could acknowledge the modification worked better than original specifications and authorize its use, which would require admitting that General Electric's sophisticated pressure valve system was fundamentally flawed. Or they could quietly drop the investigation and pretend the entire situation never happened, which is exactly what they did. On February 18, 1944, the Bureau of Ships issued Technical Bulletin Ships 4344-TR, titled Field Expedient Pressure Equalization Procedures for Mark 14th Torpedo Tube Systems. The bulletin described Patterson's rubber hose modification in careful technical language that avoided mentioning Patterson by name or acknowledging that the procedure had originated through unauthorized experimentation by enlisted personnel. Material costs were listed as approximately $1 per hour per installation using commercially available components. The bulletin noted that the modification was approved for emergency combat use, but recommended returning to original specifications during peacetime refit periods. This recommendation was universally ignored by submarine mechanics who understood that emergency combat use described every single moment of submarine operations in the Pacific War. Floyd Patterson never received his Navy Cross. The commendation disappeared into administrative channels somewhere between Pearl Harbor and Washington, lost in bureaucratic processes that preferred not acknowledging how an ex-Moonshiner's 5-cent rubber hose had exposed fundamental inadequacies in Navy weapons engineering. He continued serving aboard USS Wahoo until October 11, 1943, when the submarine was lost with all hands during its 7th war patrol in the Sea of Japan. Japanese depth charges from 3 destroyer escorts caught the Wahoo in shallow water where there was nowhere to hide and no room to maneuver. The submarine went down with Commander Morton, Lieutenant O'Kane, and 78 crew members, including Floyd Patterson, whose rubber hose modifications couldn't save them from overwhelming force, but had given them 6 months of unprecedented lethality against Japanese shipping. The modification Patterson invented outlived him by decades. Post-war analysis of submarine operations attributed approximately 63 confirmed Japanese vessel sinkings directly to improved torpedo reliability resulting from rubber hose pressure system modifications between November 1943 and August 1945. The actual number was probably higher, but combat records don't differentiate between successful launches using modified systems versus unmodified systems, and submarine commanders rarely documented which maintenance procedures their mechanics employed. The rubber hose fix remained unofficial Navy procedure throughout the war, passed from mechanic to mechanic through demonstration rather than documentation, existing in that gray zone between regulation and reality where practical solutions live when official channels move too slowly to save lives. November 24, 1943. E08 20 hours, Pearl Harbor Submarine Base, Motor machinist's mate. Second-class Floyd Patterson stood beside his sea bag watching three mechanics from USS Tang cluster around the Wahoo's forward torpedo room hatch, notebooks in hand like students at a particularly dangerous university. Chief torpedoman Walter Schmidt from the Tang had the kind of weathered face that suggested he'd been fixing broken equipment since before Patterson was born. But he was taking notes in careful block letters as Patterson explained the rubber hose modification for the fourth time that morning. The demonstration took 17 minutes, start to finish, and required one radiator hose, 2 wire ties, and the kind of careful manipulation that came from years of working with pressure systems that exploded if you got careless. Schmidt asked the question Patterson had been expecting. What happens if the external pressure ruptures the hose? Patterson's answer came from 15 years of moonshining experience. Then you've got bigger problems than a ruptured hose, because if pressure's high enough to blow out reinforced rubber, your hull's probably already compromised. Schmidt nodded slowly, understanding flooding through his expression. This wasn't sophisticated Navy engineering. This was battlefield improvisation by someone who understood that simple systems failed predictably, while complex systems failed catastrophically. By 1100 hours that same day, the Tang's mechanics had installed Patterson's modification on all 10 torpedo tubes using materials purchased from the Pearl Harbor Navy Exchange for $185. The Wahoo departed for its 6th war patrol on November 13, 1943, heading northwest toward the Sea of Japan through Le Pérouse Strait, the narrow passage between Hokkaido and Sakhalin Island that Japanese forces considered their protected home waters. Commander Morton had pushed for this patrol over objections from cautious staff officers who correctly noted that the Sea of Japan was heavily patrolled, poorly charted, and studded with minefields that made navigation suicidal for submarines. Morton's counterargument was characteristically direct. Japanese merchant ships sailed those waters precisely because they felt safe from American submarines, which made the Sea of Japan the richest hunting ground in the Pacific if you could survive long enough to exploit it. Patterson's rubber hose modifications proved their worth on November 17th, when the Wahoo encountered a convoy of 4 cargo ships escorted by 2 destroyers approximately 80 miles west of Tsushima Island. Morton submerged to 140 meters, stalked the convoy for 3 hours waiting for optimal positioning, then closed to 1,200 yards and fired a spread of 6 torpedoes from tubes 1 through 6 in rapid succession. Every tube functioned perfectly despite depth, water temperature of 54 degrees Fahrenheit, and external pressure that would have frozen the unmodified GE valves solid. 3 cargo ships went down in 17 minutes, carrying approximately 12,000 tons of supplies intended for Japanese garrisons in Manchuria. The 2 destroyers counterattacked with depth charges that came close enough to crack ceramic coffee cups in the galley, but the Wahoo escaped using the same thermal layer tactics that had saved them on November 7th. What Patterson and Morton didn't know was that Japanese naval intelligence was beginning to notice patterns in submarine attack effectiveness. Between November 1943 and January 1944, American submarine attacks in previously safe Japanese home waters increased in both frequency and success rate by margins that suggested either dramatic improvements in submarine technology or fundamental changes in American tactical doctrine. Japanese anti-submarine forces, already stretched thin protecting convoy routes across the Pacific, found themselves unable to provide adequate protection even in waters they controlled absolutely. The mathematics were brutally simple. American submarines could now launch torpedoes from depths and conditions that had previously made attacks impossible, which meant Japanese merchant ships were vulnerable anywhere, anytime, regardless of escort strength. The USS Tang's first patrol with Patterson's modifications began on December 8, 1943, with Commander Richard O'Kane commanding. O'Kane, who had served as executive officer aboard Wahoo under Morton before receiving his own command, understood exactly what Patterson's rubber hose system meant for submarine tactics. Between December 8th and December 30th, the Tang engaged Japanese shipping 11 times, launching torpedoes from depths as low as 165 meters, in conditions that would have made attacks impossible using unmodified pressure systems. O'Kane's aggressive tactics, enabled by reliable torpedo tubes, resulted in 8 confirmed sinks totaling approximately 31,000 tons of Japanese shipping destroyed in 3 weeks. By January 1944, Patterson's modification had spread through the submarine fleet like a virus, transmitted through informal networks of mechanics who shared information at Pearl Harbor, Brisbane, and Fremantle. The modification's unofficial nature created a strange parallel maintenance infrastructure where submarine mechanics installed, serviced, and improved rubber hose pressure systems, while official maintenance manuals contained 0 references to their existence. When Bureau of Ships inspectors visited submarines, mechanics simply removed the rubber hoses before inspection and reinstalled them afterward, a process that took approximately 30 minutes per boat and was considered standard procedure by everyone actually fighting the war. USS Silversides adopted the modification on January 12, 1944. Between January 15 and February 8, Lieutenant Commander John Coy's crew sank 9 Japanese vessels using torpedoes launched from extreme depths during daylight submerged attacks that had previously been considered too risky because torpedo tube reliability decreased when launching from below 100 meters. The Silverside's success rate jumped from approximately 35% to 81%, an improvement that Coy attributed to enhanced crew training and superior tactical positioning in his patrol report, carefully avoiding any mention of rubber hoses or unauthorized modifications that might trigger investigations. USS Harder received the modification on January 20, 1944, installed by Chief Machinist's mate Arthur Garrison, who had learned the procedure from Patterson during a 2-hour conversation at the Pearl Harbor submarine-based torpedo shop. Commander Samuel Dealey, the Harder's captain, was initially skeptical of modifications that violated Navy regulations until Garrison explained the physics using language so simple that even non-mechanics could understand. Complicated valves stick when stressed. Simple pressure crushes them open regardless of internal condition. We're replacing precision with reliability. Dealey authorized installation with one condition. Garrison would personally maintain the system and accept full responsibility if it failed during combat. The Harder's third patrol, conducted between February 7th and March 3rd, 1944, became a masterclass in submarine warfare enabled by equipment that worked when needed. Dealey attacked Japanese shipping with aggression that bordered on reckless, knowing his torpedo tubes would function at any depth in any condition. The submarine sank 5 destroyers in 8 days, an achievement unprecedented in submarine combat, made possible because Dealey could maneuver aggressively without worrying whether his weapon systems would function when he pressed the firing button. The total Japanese tonnage destroyed on that patrol exceeded 15,000 tons, and Dealey's tactics became required study material at submarine school despite the fact that his success depended partly on unauthorized modifications that officially didn't exist. The Japanese response to American submarines' improved effectiveness revealed their fundamental misunderstanding of what they faced. Intelligence officers analyzing submarine attack patterns concluded that Americans must have deployed a new submarine class with enhanced torpedo systems, possibly magnetic homing torpedoes that explained increased hit rates. This assumption led to tactical countermeasures designed to defeat sophisticated American technology, including acoustic decoys and magnetic field disruptors that cost millions of yen to develop and deploy. The actual American advantage was 5-cent rubber hoses installed by mechanics who understood that reliability mattered more than sophistication. By March 1944, approximately 68 submarines in the Pacific Fleet operated with some version of Patterson's modification. Variations had emerged as different mechanics adapted the basic concept to specific submarine classes and local material availability. USS Barb's mechanics used heater hoses instead of radiator hoses because heater hoses were thicker and provided more crushing force. USS Trigger's crew installed pressure gauges on their rubber hose systems to monitor performance, creating the Navy's most sophisticated application of an inherently crude fix. USS Wahoo's mechanics, maintaining Patterson's original installation after his death, kept detailed logs showing that their rubber hoses had been used successfully in 47 separate torpedo launches without a single failure. The modification's success created unexpected problems for torpedo production planning. The Mark 14 torpedo's notoriously poor performance between 1941 and 1943 had been attributed to multiple factors. faulty depth control mechanisms, defective magnetic exploders, and unreliable pressure equalization in launch tubes. The Naval Torpedo Station at Newport had invested millions of dollars redesigning depth control systems and magnetic exploders. But torpedo tube pressure equalization problems had been considered secondary issues that could be addressed through improved maintenance procedures and minor valve redesigns. Patterson's modification proved that the pressure equalization problem wasn't minor and couldn't be fixed through better maintenance. In April 1944, the Bureau of Ships quietly commissioned an investigation into torpedo tube reliability improvements observed across the submarine fleet. The investigation team, consisting of 3 civilian engineers from General Electric and 2 Navy ordnance specialists, visited Pearl Harbor with instructions to identify technical factors contributing to improved launch success rates. What they discovered horrified the engineers and amused the submarine mechanics. Dozens of submarines were operating with unauthorized pressure system modifications that violated every principle of proper engineering practice. The modifications worked better than GE's design system. The modifications had been installed by enlisted personnel without authorization. The modifications cost less than $2 per submarine to implement. The investigation report, classified secret and filed with the Bureau of Ships on May 3, 1944, contained technical analysis that essentially admitted General Electric had over-engineered the Mark XIV's pressure equalization system to the point of creating failure modes that wouldn't have existed with simpler designs. The report's conclusions were diplomatic but devastating. Observed field modifications achieve superior performance through reduced mechanical complexity and elimination of thermal stress failure points present in originally designed valve assemblies. Recommend evaluation of field modification principles for incorporation into future torpedo tube designs. The recommendation was ignored. General Electric had military contracts worth approximately $47 million for torpedo tube components, and admitting that their sophisticated valve systems were inferior to rubber hoses would have invited contract reviews, congressional investigations, and potential fraud allegations. Instead, the Bureau of Ships issued a carefully worded technical bulletin authorizing emergency field expedient pressure assistance procedures that described Patterson's modification without crediting its source or acknowledging it worked better than original equipment. The bulletin's legal language transformed an unauthorized fix into a sanctioned procedure while avoiding admission that Navy specifications had been fundamentally flawed. Commander Richard O'Kane, by then commanding USS Tang and well aware of how Patterson's modification had enabled his success, attempted to have Patterson posthumously recognized with official commendation. O'Kane submitted detailed documentation showing that Patterson's innovation had directly contributed to the sinking of at least 63 Japanese vessels by multiple submarines between November 1943 and May 1944. The Bureau of Naval Personnel rejected the commendation request on grounds that recognizing unauthorized equipment modifications would encourage other personnel to violate regulations, potentially creating safety hazards. This reasoning ignored the obvious reality that Patterson's modification had already spread throughout the submarine fleet and had demonstrably saved American lives while destroying Japanese shipping. The human cost of official reluctance to acknowledge Patterson's contribution became tragically clear on October 11, 1944, when USS Wahoo was lost with all hands during its 7th war patrol. The submarine had been operating in the Sea of Japan, hunting shipping in the same waters where Patterson's modifications had enabled Morton's aggressive tactics during previous patrols. Japanese anti-submarine forces, having learned from months of devastating submarine attacks, had concentrated destroyer escorts and aerial patrol aircraft in response to American submarines' improved effectiveness. The Wahoo was caught by 3 destroyer escorts in shallow water near La Perouse Strait and destroyed by depth charges that gave the crew no chance to escape. Patterson's death meant that knowledge of his modification's origin was lost to official history. Post-war submarine force records credit improved maintenance procedures and field modifications by submarine mechanics for increased torpedo tube reliability after November 1943, but specific attribution to Patterson appears in exactly 0 official documents. His service record lists him as Motor Machinist's Mate 2nd Class, lost with USS Wahoo on October 11, 1944, posthumously awarded the Purple Heart. No mention of rubber hoses, pressure systems, or the innovation that changed submarine warfare. His family in Cocke County, Tennessee, received notification of his death with standard condolence language about his sacrifice and service, carefully omitting the detail that his illegal moonshining experience had contributed more to American victory than most admirals. The modification's long-term impact on submarine operations became measurable through statistics that Navy analysts carefully avoided connecting to unauthorized pressure system fixes. Between November 1943 and August 1945, American submarines sank approximately 1,300 Japanese merchant ships totaling 5.3 million tons, plus 201 Japanese naval vessels. Torpedo launch success rates improved from roughly 40% in early 1943 to over 85% by late 1944, an improvement that analysts attributed to better torpedoes, improved crew training, and superior tactics. All of these factors contributed, but the single most significant technical improvement was Patterson's 5-cent rubber hose that allowed torpedoes to launch reliably from depths and conditions where they had previously failed. Japanese merchant marine losses directly attributable to improved American submarine effectiveness created cascading economic impacts that fundamentally shaped the Pacific War's outcome. Japan's island economy depended entirely on merchant shipping to move raw materials from conquered territories to home islands for processing into military equipment. Every cargo ship sunk meant fewer aircraft engines, less ammunition, reduced fuel supplies for the combined fleet. By 1944, Japanese war production was collapsing not because American bombers destroyed factories, but because American submarines destroyed the cargo ships that fed those factories. Patterson's modification, proliferating through the submarine fleet, contributed to this industrial strangulation in ways that strategic bombing never achieved. The modification's influence extended beyond World War II into the Cold War submarine force that emerged in the 1950s. Naval architects designing the new generation of nuclear submarines studied wartime submarine operations to identify lessons learned and best practices. One consistent finding was that complex pressure equalization systems had failed repeatedly under combat stress, while simpler backup systems proved more reliable. The Skipjack-class submarines, entering service in 1959, featured torpedo tube pressure equalization designed around redundant, simple systems rather than sophisticated single-point mechanisms. The design philosophy directly reflected lessons learned from Patterson's rubber hose, though official documentation avoided mentioning moonshine stills or enlisted mechanics with criminal records. Chief Torpedo Man Walter Schmidt, who had learned Patterson's modification on November 24, 1943, and installed it aboard USS Tang, survived the war and eventually became an instructor at submarine school in New London. Schmidt taught pressure system maintenance to 3 generations of submarine mechanics between 1946 and 1967, always emphasizing that reliability trumped sophistication in combat equipment. His lectures included practical demonstrations of field-expedient repairs using common materials, though he carefully avoided mentioning that these techniques originated with an ex-moonshiner who had learned fluid dynamics making illegal whiskey. Schmidt's students spread throughout the Cold War submarine force, carrying with them the fundamental lesson that Patterson had demonstrated. Simple solutions often work better than complex engineering when lives depend on equipment functioning under stress. The economic legacy of Patterson's innovation appeared in unexpected ways during the 1950s, when Congress investigated wartime military procurement. Testimony revealed that the Navy had paid General Electric approximately $23,000 per torpedo tube pressure equalization valve assembly during the war, despite the fact that field mechanics routinely bypassed these assemblies with modifications costing less than $2. Congressional investigators questioned why the Navy continued purchasing expensive components that submarine crews immediately replaced with hardware store materials. Navy officials provided carefully evasive testimony explaining that official specifications required precision-manufactured components regardless of field experience with alternatives. The investigation concluded with recommendations that were diplomatically phrased, but essentially said the Navy should listen to its mechanics more and its contractors less. Floyd Patterson's uncle Jesse, who had taught him moonshining and pressure system maintenance in the Tennessee mountains during the 1920s and 1930s, died in 1956 without ever learning that his nephew's wartime service had changed submarine warfare. Jesse Patterson's obituary in the Cocke County newspaper mentioned that he had been a skilled craftsman and entrepreneur, which was polite Tennessee language for acknowledging he'd run one of the county's most successful illegal whiskey operations. The obituary didn't mention that his fundamental lesson about simple pressure systems being more reliable than sophisticated ones had been applied to torpedo tubes throughout the Pacific submarine fleet, because nobody in Cock County knew that connection existed or that illegal moonshining and submarine warfare shared common engineering principles. The modification's recognition came indirectly through awards given to submarine commanders whose success depended partly on equipment that officially didn't exist. Commander Richard O'Kane received the Medal of Honor for his service commanding USS Tang, with citations crediting his aggressive tactics and superior seamanship. No mention of rubber hoses that made those tactics possible. Commander Samuel Dealey received the Medal of Honor posthumously for his service commanding USS Harder, with citations describing his destruction of 5 destroyers in 8 days. No mention of unauthorized pressure system modifications that allowed him to launch torpedoes from extreme depths. Lieutenant Commander John Coy received the Navy Cross for his service commanding USS Silversides, with citations praising his tactical innovation. No mention of field-expedient repairs using radiator hoses and wire. The last submarine to operate with Patterson's original modification was USS Pampanito, which kept the rubber hose system installed until the submarine was decommissioned in 1945 and eventually became a museum ship in San Francisco. The modification remained in place, hidden behind access panel TR-47, until museum restoration workers discovered it during a maintenance inspection in 1982. The workers, confused by rubber hoses in the torpedo tube pressure system, consulted Navy technical manuals and found 0 references to this installation. They removed the modification, assuming it was unauthorized field repairs that should be corrected during restoration. The radiator hose, wire ties, and connection to the high-pressure air system were discarded as unhistorical additions that didn't match original specifications. They were wrong. That modification was more historical than the precisely restored GE pressure valves that replaced it, because that modification represented how submarines actually fought the war, rather than how engineers designed them to fight. The rubber hose system that museum workers threw away in 1982 was a direct descendant of Patterson's November 1943 innovation, installed by mechanics who understood that combat required equipment that worked reliably under stress. Removing it to restore original specifications was technically correct and historically misleading, because original specifications described submarines as they left shipyards, not submarines as they fought and won the Pacific War. The final accounting of Patterson's impact requires mathematics that official records make impossible to calculate precisely. 63 Japanese ships are definitively attributable to submarine attacks enabled by improved torpedo tube reliability between November 1943 and August 1945. The actual number was probably higher, possibly much higher, because patrol reports don't specify which mechanical systems functioned during attacks, and submarine commanders had every incentive to avoid mentioning unauthorized modifications in official documentation. Conservative estimates suggest Patterson's innovation contributed to the destruction of at least 200,000 tons of Japanese shipping, possibly as much as 500,000 tons, carrying supplies that never reached their destinations and troops who never reinforced their garrisons. The strategic impact of this tonnage destruction exceeded its immediate military value. Every cargo ship sunk weakened Japanese logistics, forcing their military to make increasingly desperate decisions about resource allocation. Every tanker destroyed reduced fuel available for aircraft and warships, limiting Japanese military operations even when equipment remained functional. Every transport sunk prevented troop reinforcements from reaching embattled garrisons, hastening their defeat and reducing American casualties in subsequent amphibious operations. Patterson's 5-cent rubber hose, proliferating through 68 submarines, contributed to this cumulative degradation of Japanese military capability in ways that individual battle victories couldn't achieve. Motor Machinist's Mate Second Class. Floyd Patterson received no recognition beyond the standard Purple Heart awarded posthumously to all personnel lost in combat. His name appears on the memorial wall at the Submarine Force Museum in Groton, Connecticut, listed alphabetically among the 3,505 American submariners who died during World War II. Visitors walking past that wall have no way of knowing that Patterson's contribution to submarine warfare exceeded most admirals' strategic planning, or that his illegal moonshining background provided engineering insights that Naval Academy graduates missed, or that his death aboard USS Wahoo on October 11, 1944, eliminated the only person who could explain exactly how a Tennessee bootlegger's understanding of pressure systems had changed the Pacific War's outcome. The story of Patterson's rubber hose modification ultimately illustrates the distance between official recognition and actual impact. Military history remembers admirals who planned operations, submarine commanders who executed attacks, and industrial leaders who built equipment. It rarely remembers enlisted mechanics who fixed broken systems using improvised solutions that violated regulations but saved lives and won battles. Patterson's innovation worked because he understood that sophisticated engineering sometimes created problems that simple solutions fixed, that official specifications sometimes prioritized manufacturer profits over combat effectiveness, and that Tennessee moonshine stills shared fundamental pressure system principles with Navy torpedo tubes. His legacy endures not in official records, but in the persistent submarine force culture that values practical solutions over theoretical elegance, field experience over engineering credentials, and results over regulations. Modern submarine mechanics, working on nuclear-powered boats that would seem like science fiction to World War II crews, still occasionally encounter situations where simple fixes work better than sophisticated systems. When they do, they're channeling Floyd Patterson's fundamental insight. Complicated things fail in complicated ways, but simple things either work or they don't. And in combat, reliability matters more than sophistication. The rubber hose modification that Patterson invented on November 7, 1943, saved USS Wahoo that morning, enabled the destruction of 63 Japanese ships over the next 21 months, spread through 68 American submarines despite being officially unauthorized, cost approximately $150 per installation using hardware store materials, violated multiple Navy regulations, worked better than the system it replaced, and was forgotten by official history because acknowledging it would have required admitting that a former moonshiner understood pressure systems better than General Electric's engineers. That's the real story of how American submarines won the Pacific War's tonnage battle. Not through superior technology or better tactics alone, but through mechanics who knew when to bypass the sophisticated systems and use simple solutions that actually worked.